Hello everyone, welcome to this session. In this session, we will talk about a few key concepts in machine learning. So in the last session, we talked about a machine learning model, right? And so now we will start from this. So a model we can think as by applying for some machine learning algorithms and a given data set. So we have a specific representation of the machine learning outcome. So we call this is a model. So once the model is trained, it can be used to predict new things that does not appear in the data set before. So for example, we want to predict a fruit, and the data set is a fruit image data set, and the model is trained. Then after that, the model can recognize a fruit, and this fruit was not given before. So for example, I give this green apple to the model, and this model is trained by this data set. So we can see that this green apple is not included here, right? Then we obtain a trained model. Using this new one, the green apple, we can tell if it's an apple or not an apple. So this is a machine learning model. What does it do? And the machine learning model, as I've said, is trained by the data set. So for example, this is a data set example, right? So we can see data set we think is a collection of data, right? So for the machine learning model to be trained, we can say it's like D equals to D1, D2, Dn, right? So n is the size of the data set. So in the fruit example, we can see the size of the data set is 6, right? So all of them are the fruit images. For each of the element in the data set, we call it a sample. So a sample is an element in the data set. So given this data set, D1 to Dn, so we give a smaller n. Dn is nth sample of the data set. So in this particular example, the nth data set of a fruit is an image and its name. So we can see here is an image, this is this one, and its name together. We call this a sample, right? So now we know the data set and sample. So normally in a data set, if you supervise learning, so we often partitioned the data set into the training data and the test data. So these are of different use. So the training data is to train the machine learning model, to obtain the model using this data. Normally, the size of the training data is much more than the test data. So for example, I use 70% of the total data to train the model. The test data have another performance. It's not used to train the model, but to test if a trained model works well or not. So we say the test data set is used as a benchmark to evaluate a trained model. So we can say the training data, test data, these two data must be independent. The two data set must be very independent to make sure the test data set can correctly evaluate the trained model, right? So later in the advanced class, you will see more about this. And as well as later, we will talk about how to split the training data and the test data, right? So the size of the test data is often approximately, let's say 20 to 30% of the total data. So this is just an empirical number, right? About 20 to 30%. So if we see we have a data set, we can put someone, let's say more than 60% as a training data set to train the model. And we can say the 20 to 30%, we use them as a test data, right? To evaluate the model. So this is a training and a test data set. So for each sample of the data, another concept is a feature. So we see feature is a measurable property of the data. So a set of features, more than one, we often call them a feature vector. So the feature vectors, they are indeed the input to the machine learning model to train it, right? So let's again see the fruit example. So for this fruit, we may say the feature of each element to be from F1 to F4. So these features can be what? Can be, let's say, the color, the shape, the smell, the taste, etc. The properties of this food, right? So by collecting them, we can form a feature vector like this, right? So this is the feature vector, include all of these features. The feature vectors are the same for all the samples. Then the machine learning, the real input is this feature, right? So the input is a feature, that what is the output? So the output, we call it, this is a label, right? This is the label of, this is the label is the output of the training data, and this is the value to be predicted by the model, right? So this is the label. So for the, let's say the fruit example, the label is what? Is a class or the name of the fruit. So for example, we say this is we can extract the features from this peach, and the label is a name peach. So this is a label. So now we have learned the feature, the label, the sample, the data set, and using them, we can train a model, right? So that's all for the concepts in this session. Thank you very much.